with water and you put your index finger inside it. You'll observe that the water level rises slightly. You put in 2 fingers, the water level rises a bit more. And now when you put in your hand up to the wrist level, you'll see that the water level increases significantly. The ancient Greek mathematician Archimedes observed something similar when he got into a bathtub. When he got in, he realized that the level of water went up. In both the cases, you notice that the water is displaced by the object that goes in. Keep this thought in mind. We'll come back to it soon. In our previous videos, we've seen that when an object is placed in or on the fluid exerts a buoyant force on it which acts upwards. The Archimedes principle goes just one step further in saying that the buoyant force applied by the fluid is equal to the weight of the displaced fluid. We can take a simple example to understand this. Take a 5 kg solid object and suspend it by a spring balance. The balance will read 5 kilograms. Let this be the first case. For the second case, take a beaker of water which has a small opening at the top. The water in the beaker is filled right up to this point where the opening is. And we keep a small container under the opening. Now slowly lower the solid object into the water and you'll see that the reading will be lower number as compared to the previous case. Why is that? It's because of the buoyant force acting on the object. You'd have also noticed that some water was displaced. Now in this context, we can say that the weight of this displaced water is equal to the magnitude of the buoyant force acting on the object. That's the Archimedes principle. When an object is immersed fully or partially in a fluid, the upward force applied by the fluid on the object is the same as the weight of the fluid displaced by the object. Where is this principle applied? Can you think of examples? How do you think large steel ships float? It's simple. If the weight of water displaced by the vessel below the keel is equivalent to the vessel's weight, then everything above the keel will remain afloat. That's